So our second learning unit is on atoms, molecules, and ions. So to begin this discussion, we actually just have to talk about what atoms are and how we can organize information about atoms and elements on the periodic table. So the first slide here kind of introduces us to how we think about representing atoms using an atomic symbol and talking about mass numbers and atomic numbers. So first, when we think about atoms, we have to think about what actually makes up atoms. And so when we think about what makes up atoms are made up of three things: protons, electrons, and neutrons. So we need to think about the charge that these species have, the mass that they have, where they're located, and what they do in terms of identifying something special about an element or an atom. So let's start with protons. Protons we can abbreviate with the letter P. Protons have a +1 charge. They have a mass of 1 atomic unit. They're located in the nucleus, and they're very special because their number is, again, the atomic number that tells us the chemical identity of that species. Electrons we can abbreviate with E, and we say E- because electrons have a -1 charge. There's relatively no mass with electrons. They're located outside of the nucleus, and generally their number is the same as the number of protons that we have for a neutral atom. If we have more electrons than protons, we're going to have an anion. If we have fewer electrons than protons, we're going to have a cation. We'll get more to that in just a little bit. So when we represent sort of information about an atom, we're going to use the atomic symbol, and the atomic symbol is just what we have on the periodic table. I will say you're going to need to know pretty much all of the atomic symbols through atomic number 40. There's a few other key ones that we'll know, and they're probably ones that are familiar to you, things like silver and gold and mercury, but pretty much guarantee that you're going to want to know the atomic symbols for anything with an atomic number 40 or less. That's through calcium. So again, the atomic symbol is what we use as sort of the abbreviation for that element. The atomic number reflects the number of protons, and again, that's going to be the chemical identity of a species. So things that are the same element will have the same number of protons. And we're going to talk about isotopes in just a minute. Isotopes have the same number of protons, so chemically they're the same element, but they have different number of neutrons. The mass number really reflects the sum of the number of protons and neutrons. Remember, neutrons and protons are the things that have mass within our atom. I may not have mentioned here, because I mentioned protons and electrons. Neutrons, we abbreviate with the letter N. Neutrons have no charge, like the name neutron, neutral implies. Again, they have a mass of 1 atomic unit. They are found with protons inside the nucleus, and their number is going to be variable, and that's defined by the isotope. So isotopes, again, are going to be species of an element that are the same, so they have the same number of protons, that same chemical identity, but they differ by the number of neutrons, which makes them have differing atomic masses. So here's an example, our 2 isotopes of uranium. We know it's uranium because they both have 92 protons. That's the chemical identity of uranium. But they have differing numbers of neutrons. Here there's 143 neutrons and 146 neutrons. That gives us isotopes that have different atomic masses. So we'd say that this is uranium-235 and uranium-238. Understanding kind of the chemical reactivity of isotopes is going to become more important in a skill that we'll have in general chemistry too. Lastly, we want to think about what the periodic table is. You will always have a periodic table available for you. You can think of the periodic table as your best cheat sheet if you understand how it's organized and the information that it can provide. So just looking at the color scheme of the periodic table, anything that's in blue represents something that's a metal, and they tend to be found on the left side of the periodic table. Anything that's a non-metal is going to be on the right side of the periodic table. And things that are sort of having properties of both metals and nonmetals, and we call those metalloids, we're going to find in these green section here. So when we think about how the periodic table is organized, it's really organized into columns and rows that represent similar chemical properties that we have. You actually can find periodic tables for lots of things that are of interest, and really it's just a classification scheme based on things that are similar in property. So what we see is rows in the periodic table that we call periods. And as you go across a period from left to right, you're going to increase in mass because you're adding protons and you're also adding numbers of neutrons. So those are our rows or our periods. Our columns are going to be what's most important in terms of classifying things by chemical reactivity, because things are classified in these columns or groups because they have similar chemical properties. And that similar chemical property comes from the fact they have similar numbers of valence electrons. So we're going to go through some important groups that we have here on the periodic table. And one thing we're going to highlight is the importance of the number 8 on the periodic table. Every atom would like to have 8 electrons in its outer shell. And so what it does to get to 8 electrons either has to do with it losing electrons or gaining electrons. So let's start here over on the left side of the periodic table with 2 columns, 2 groups that are going to become important. The first is group 1, which are the alkali metals. That 1 tells us that there's 1 valence electron in these elements. 1 valence electron means, you know what, I'm going to lose that 1 electron, and that way I'm going to have 8 underneath it, and that's going to make me happy. Losing 1 electron is going to give that atom a positive 1 charge. It's going to make it a positive 1 cation. Group 2 atoms, or group 2 elements, we call the alkaline earth metals. They have 2 electrons in their outer shell, 2 valence electrons. So they like to lose those 2 electrons and they will generate plus 2 cations. So things that are on the left side of the periodic table, these metals like to lose electrons and become positively charged. Things that are on the right side of the periodic table as nonmetals like to gain electrons. So let's start with group 6 here. Group 6 is the oxygen family. That 6 tells us that there's 6 valence electrons in the outer shell. To get to that magic number of 8, they're not going to lose 6 electrons. They're actually going to gain 2. And by gaining 2 things that are negatively charged, you actually have a minus 2 charge. So these are going to be minus 2 anions. Things that are negatively charged we call anions. Group 7, having 7 electrons in their outer shell, are what we call the halogens. They like to just gain 1 electron to give them that magic number of 8. So they will generate minus 1 anions. And some things exist on the periodic table already having that magic number of 8. And we call those the noble gases. They're generally unreactive because they don't like to gain or lose any of their electrons. So again, the mass on the periodic table is not going to be a whole number because we need to take into account the relative abundance of isotopes. So if you look at what we see here in terms of atomic masses, they're not whole numbers. So we'll work through in some homework problems how to think about and rationalize that. So that's the periodic table, and again, knowing how to use it, it can be your best cheat sheet that you'll have